Hi guys, it's Miss Olton. I decided to film today's lesson from our classroom. Anyway, today we're going to be talking about the carbon cycle. Last time we talked about how carbon affects our climate, especially because carbon dioxide is a greenhouse gas. So we need to talk about how does carbon move through our environment from living things like us and plants to non-living things, and where is it being stored? So we're going to look at that today. So there's some questions we're going to hopefully answer. Is that we're going to review the carbon cycle real quick. Hopefully this is not new to you. You've talked about the carbon cycle before from middle school. But we're also going to talk about how does carbon dioxide get into the atmosphere? Because remember, that's where we're concerned about it at. It's a greenhouse gas. And I want to take a moment before we really get started here, and I'll continue. Remember, if I go too fast at any point, please don't hesitate to pause me, okay, guys? All right, so let's go back. We're going to talk about the carbon cycle. We're going to talk about how that carbon dioxide gets into the atmosphere. Remember, it is a greenhouse gas. It's one of those gases that traps heat. So we're going to talk about that. How does it get out of the atmosphere? So how does it get from the atmosphere into living things? How does that work? And then where is it mostly being stored right now in our Earth? Where can we find very large amounts of carbon? So we're going to kind of talk through that. So the best way to do this is to talk you through a picture. So we have focused on atmospheric CO2 because that's the greenhouse gas. It's the gas that helps trap heat next to our planet. Very important to have it, but having too much of it can affect our climate. So let's talk about ways it gets into the atmosphere. You're going to notice all these red arrows, guys. All these red arrows are ways that we are putting CO2 into our atmosphere. Okay, so one of the ways it is through just respiration, us simply breathing out like that, right? We breathe in oxygen, we breathe out CO2. Now this is just very minute amount that we put out there, but yes, animals and humans and any living thing that does respiration is putting CO2 back into the atmosphere. Same thing with CO2 exchange from the ocean. The ocean is one of our larger carbon sinks. There's a lot of living things in the ocean, and so there is the exchange of carbon dioxide from the ocean into the atmosphere and vice versa. Especially we'll talk about how it gets out in a minute. And then there's burning fossil fuels. Okay, so burning things like petroleum and coal, so driving cars, making electricity, all those things release CO2 into the atmosphere. There's other ways, cow farts, yeah, you guys, methane puts a lot of CO2 in the air, and also other natural ways would be like volcanic eruptions and forest fires will put a lot of CO2 back into the atmosphere. But ways that we use them, and I mean, why is burning fossil fuels going to put CO2 in the air? Because fossil fuels are made of carbon. When things die, they decompose, like you can see down here. And then after a very long time, we'll talk about this in a minute, they get changed. That carbon, as the dead thing decomposes, it releases carbon back into the ground. And over time, that carbon changes thanks to heat and pressure into things like coal and petroleum. And then humans use them. And so we put CO2 back in the air. So those are all the ways CO2 gets into our atmosphere. So how do we take it out? Because it's a cycle, there's got to be a balance. Well, the main number one way is photosynthesis. Plants. Plants are extremely important. Plants take the CO2 out of the atmosphere and they turn it into food, glucose. It's how we get our energy. It's an extremely important process. Without photosynthesis, we all die. So that's really important. So having lots of trees and plants that do photosynthesis is extremely important. And later on, we're going to talk about how humans are impacting that through deforestation. But that is a major, major way. You'll also see that there's a lot of photosynthesizers in the ocean. They're called diatoms, and a lot of phytoplankton. So all these little microscopic organisms that live in our ocean also do photosynthesis. So they're another big player of taking it out. It's helping maintain that balance. We're putting in, but there's also living things taking it out. The biggest problem here is that the rate at which it's going into the atmosphere is a lot higher than the rate it's coming out. And so we're talking about balance here. So that's how it gets in and how it gets out of the atmosphere, CO2. So where is it found? Well, it's found in the atmosphere. We talked about that. Right now, CO2 is around us right now in the air. In the ocean is dissolved CO2 gas. It's found on land in organisms, rocks, and soil. And then way underground is fossil fuels. And a lot of these places, especially in the ocean and way underground, is going to be referred to as carbon sinks. But these are all places like you can see in this picture here, fossil, down here, it's a fossil fuel. Radioreactive sediments down here, all places where that carbon settles and then eventually becomes fossil fuels. So how do our fossil fuels get created? So the first one up here says, how is coal created? Well, you had your swamps and you have then water and dirt and plants. You have layers that started forming. And what happens is you have things die. And as things died, you had more and more layers of soil get put on top of it because you had decomposers and things like that. Rocks broke down and it made soil. And all that dead plant, it's living material. It's made of carbon, was put underneath all of these piles and piles and piles of rock and dirt and more dead things and then more and more layers. Well, eventually you get it way down in the ground where two things are affecting it. So that carbon, that dead plant material, that carbon's now under multiple and multiple layers of rock and dirt. And this increased two things, temperature and pressure. The further you go down in the earth, the hotter the temperature gets and pressure increases. Well, that changed the carbon into coal. And now we as humans, we dig up that coal and we use it and we're putting CO2 back into the atmosphere. Petroleum, which is oil, did the same thing. Once again, you had plants and animals, they died, and as more and more and more and more layers of sand and silt and rock built up on this, that carbon down there from the dead remains of plants and animals eventually became oil and gas deposits. And yes, same thing. We dig it up, we bring it back up, and we burn it, and we're putting CO2 back into the atmosphere. The thing is, we got to think about time here. It takes a lot of time for it to go from dead, decaying material to oil or coal. It's instant for us to dig it up and burn it. So we got to keep in mind the differences in time it takes. So are we forming more coal and oil and gas? Yes, but it's going to take a very long time before that happens. So why is carbon so important to us? Well, all living things on our planet are full of carbon. You're made of carbon, I'm made of carbon, plants are made of carbon, anything that's living is made of carbon. And carbon dioxide is extremely important. It is a requirement for photosynthesis. And remember I mentioned earlier, no photosynthesis, no life. If plants and the organisms in the ocean are not making photosynthesis, they're not making our glucose, our food, our fuel source, and they're not making oxygen. So extremely important. And remember, we want to have some carbon dioxide out there. Having the right amount of carbon dioxide in the atmosphere is what keeps the earth warm so life can exist. So carbon is extremely important to life. But too much is a problem. As we are burning fossil fuels, as we are releasing a bunch of carbon dioxide into the atmosphere, we're putting more in at a rate much faster than we're taking it out. And remember, that carbon dioxide traps heat and it's contributing to climate change. So we're going to talk about more and more the greenhouse effect, greenhouse gases, and how humans are impacting that. But it's important to understand that fundamentally, this is all about an imbalance in this carbon cycle, that we're putting way more carbon dioxide back in the atmosphere than we're taking it out. And so we're going to talk about that some more. All right, your assignment for today. We're going to be doing our CK12 assignment. So you're going to click on, I have the link to CK12. You should already be signed up for it. That was one of the first things you needed to do. So you're going to log into there and you'll go to your assignments and you're going to see the one that says carbon cycle. You're going to click on that. You're going to read and do a practice with it. So once you're done reading, it'll say off to the corner practice. Click on your practice. Only should take about 10 minutes or so. You have to, after reading, you'll do some questions. You've got to get 10 questions right. That's due by April 14th at 11 p.m. And then you have your Carbon Cycle Edpuzzle. You're going to, once again, click on the link on Canvas. It'll take you out to Edpuzzle. And you're going to sign in and complete the Carbon Cycle Edpuzzle there. We've done this multiple times. You're going to watch the video and answer the questions on there. I think that takes about 10 minutes. That's also due about April 14th. So this should be probably about a half hour or so, maybe 40 minutes of work. So all put together. So best of luck, guys. If you have any questions, don't forget you can reach out to me. I'm here through email at any time you need. Have a great day, guys.